Hello, I'm Hannes. I want to talk to you about MirageOS and what MirageOS is in the end. So, the contents of this talk will mostly be why MirageOS? What is it? Then the connection between MirageOS and OCaml, some case studies, and what is currently going on. If you ever feel lost, please don't hesitate to interrupt me. So, let's start at the basics. What is an operating system? Well, an operating system is something designed in the 70s for machines like that, like computers that are bigger than the fridge in the back. And these operating systems are basically, the purpose is that they communicate with the hardware and provides you as a software developer an abstraction that you don't need to write the same stuff for various different hardware architectures or network interfaces or whatever. Also, operating systems nowadays provide you an abstraction to execute multiple processes, like your web browser, like your editor, maybe also an HTTP server, and so on. So an operating system nowadays also includes stuff like user management, so you can have a laptop or also a server that has multiple different users, so-called users that have different permissions and can do different things. Also, you have usually a file system because at the end of the day, you want to store something somewhere and be able to use that data also across reboots. Also, operating systems provide you an interface for accessing the internet. As I mentioned, a lot of operating systems have been developed or started development in the early days, in the 70s. Currently, well, conventional operating systems are Windows, macOS, Linux, BSDs. All have in common that they're written in a program language called C, which is not memory safe. Has been developed in the 70s as well. So it's a pretty old language. It's pretty hard to get it right. And especially if you don't get it right, it is easily turning into an exploitable or to an issue that is exploitable, and then you have a security critical issue in your system. All of these operating systems also have in common that these are general purpose operating systems. So you can run any number of applications, and you can run your browser and your games and also a shell and your editor and everything at the same time. What they also have in common is that they have an enormous amount of legacy code bases. Like the Linux kernel still contains code for accessing floppy disk drives, and I guess nowadays in the current environment with laptops and so on, nobody has a floppy disk drive around anymore. So yeah, there's a lot of legacy code base, and it's hard to remove code from the Linux kernel because they are keen to provide all the support they have also for all the old interfaces, because maybe some person out in the world still wants to use it. So when you write applications nowadays like a web server or so, there's, or like a website or a web application, there's the code you actually care about, which is the stuff you actually do, and you do it nicely and nicely shaped and so on. And then you also have the whole code that the operating system insists that you need it. Like, as I mentioned, the user management, the file system stuff, and all of that, that you basically keep around. You can't remove it. It is always there. Also, the multiple processes and so on. So that's always around, and it will be there, and it is pretty huge. And you don't care about it, and it is a huge surface of attacks, a huge amount of legacy code that you may need to update every now and then. Or if you don't update it, it opens the path for attackers. So, here comes MirageOS. MirageOS was developed in roughly 2013, maybe a bit earlier. The first release was at least in 2013 at University of Cambridge. It was a research project back then, done by some people, or started by some people who used to work at XenSource, which is a company that developed the hypervisor called Xen. Yeah, and it started back then. Nowadays, it contains more than 150 different OPAM packages that are used across the ecosystem. So they are used in other environments, in other non-OS environments as well. MirageOS itself is used in Qubes as a firewall. I will come to that later. In Docker Desktop, at least on Windows and macOS, there the TCP/IP stack is used. There's a commercial project called NetHSM, which is a hardware security module, well, actually a software security module, that is using MirageOS. Nowadays, so the story from 2013 until now is that also there were 12 hack retreats happened in Marrakesh, in Morocco, each maybe a week, each maybe 20 to 30 participants. So that is basically the active community that contributes to MirageOS. And today, there are at least 6 people working full-time on MirageOS. What are the goals of MirageOS, you may want to ask? It's a radical approach to operating system development. So instead of building on top of the existing code base, we just removed everything and built it from scratch, purely in OCaml. We have security from the ground up, so we have much fewer code. We have up to 2 orders of magnitude less code in both binary and source code compared to Unix system. We also have fewer attack vectors because we have the memory safety built in OCaml. So it's fewer attack vectors and less attack surface. So we have actually much smaller code base, much more security. We also reduce the runtime and configuration time complexity because, for example, file system or user management is not built into MirageOS. Because in the services that I will describe soon, you will see that we don't need all of that inside of each virtual machine or inside of each Unikernel. And what I find also very important is that MirageOS reduces the carbon footprint. So it uses much less CPU cycles and much fewer memory. So it's actually much fewer resources like energy that you need to use. So here on the right, I have a dashboard from CPU usage from a MirageOS Unikernel that I first deployed on Unix, which is here the first half of the month. And you can see the CPU usage, it's pretty high and sometimes it peaks. And then at this day, I stopped the Unix service and I just ran it as a standalone MirageOS Unikernel. And there you can see an immediate drop of at least an order of magnitude less CPU cycles that were used. And that is a Unikernel, well, that is a service that runs a calendar server and that provides the very same interface. So the same behavior for clients. So the code, well, the code didn't change. The OCaml code didn't change. What also didn't change is the external observable behavior. Only what changed is that the execution environment changed. So instead of using a full Unix virtual machine and on top of that an OCaml process, I used MirageOS Unikernel. So these are the goals of MirageOS. And I like this quote that perfection is not achieved when there's nothing more to add, but when there's nothing left to take away. So MirageOS is really minimalistic. We try to not put all the features into the operating system, but we try to figure out what is the minimal set of stuff we actually need for getting this up and running. So the next topic is why MirageOS and how do we get there? So in a conventional operating system, you have a huge stack where you have some stuff that is happening in the kernel, that is network stack, file system, the kernel threads, so scheduler. Then you also have user processes. That is all inside of the kernel, so that's all kernel code. And then in user space, in so-called user space, you also have a language runtime, the application binary, configuration files, and so on. And that is needed for running a service on your server. And that is a pretty huge amount of code and a pretty huge complexity, where if your server just serves a single page, for example, a single web page, then maybe the user processes and file system are not really needed, because why would you need that? I mean, doesn't make sense. So in MirageOS, we started from scratch with a different approach. So we say, oh, we have a Mirage runtime, which is basically the OCaml runtime. And the OCaml runtime depends on a bit of C code, so we also have to provide some C functionality in order to get the OCaml runtime running without a kernel and without a libc. And then we have the application code, and the application code is just OCaml code. So yeah, the stack is a bit smaller, let's say that, and a bit less complex. So it's also easier to reason about it, and it's also easier to debug and to get into the code. MirageOS is developed completely in OCaml. It uses a value passing style in OCaml, so it doesn't use I/O implicitly, so it doesn't call Unix.read and Unix.write and so on, but it uses that explicitly. So usually when we develop MirageOS libraries, we start by having an interface or having a pure interface that is value passing style. And that pure interface is then at the next layer or in a separate open package is then used by, for example, LWT or Vue or async or Unix or EIO or so. And one example of that is the OCaml TLS package that is also nearly a decade old. And inside of MirageOS, we still use LWT and have an LWT event loop. So LWT is a lightweight concurrent tasks library developed by the Oxygen project, which is really a really nice abstraction, which is basically green threads. So you don't have processes, operating system processes, but you just have very small tasks that you asynchronously operate. So what is a MirageOS unikernel itself? Well, it is a statically compiled ELF binary. So it is a statically compiled Unix application or a binary that is there. You can execute it as a virtual machine, but you can also execute it as a Unix application. So you can have both. You can develop and debug it as a Unix application and then deploy it as a virtual machine. For the virtual machine code, there's a lot of virtual machines coming along. And as I mentioned earlier, originally it was developed by people who were knowing a lot about Xen and were into Xen. So the primary target of MirageOS was also Xen. But over the years, we actually managed to develop further targets, and now we are using a lot of different hypervisor technology like KVM and VMM and Beehive, but also Xen, also VirtIO. VirtIO is an abstraction that is a protocol or a more standardized abstraction. Then also Muon Linux ZecComp is also a nice target for MirageOS. And also Unix, as I mentioned. And for getting this abstraction there, there's nowadays a project called Solo5 that acts as the host system process. So that is running in the host system, consuming resources there, and then executing the MirageOS unikernel as inside of a virtual machine. But something needs to be there in the host system in order to allocate the resources and allocate the network and block devices and pass them on to the unikernel. And as I mentioned, network and block devices are basically the only devices and the only resources we have in MirageOS. I mean, obviously we have some sort of memory and you can assign a certain amount of memory as you like, but network and block devices are the only devices that we have and that we care about. And network devices are basically layer 2, so basically it's a virtual Ethernet cable that you can plug, and then you can connect your unikernels to wherever you want them to live. So let's jump a bit into code, because I mentioned that MirageOS is developed in OCaml. And here is the very first Hello World unikernel, which, so the purpose here is, I want to show you the code, what it means for a Mirage unikernel to be there, and what does it need in order to start. And we start here at the cursor location here, at the let's start. The let's start is basically the function definition where the unikernel boots up to, and where the unikernel then is started. And the start gets 2 arguments in this case. One is an unused parameter, time, and the other one is hello. And then it defines a recursive function called loop. And in the loop, it logs, so it prints out on the console output, it prints out the content of hello, then it sleeps for a second, and then it loops with a decremental value. So it loops 4 times, prints out hello world. Now, the hello is some argument, and the argument is actually defined up here using a command liner, which is a nice package developed by Daniel Binsley in OCaml to process command line arguments, and we use the same. And hello is just a string. By default, it's hello world, and that's how it is put together. So that unikernel basically is all you need to print out hello world 4 times. Now, as you can see here, we have also some boilerplate or some functors coming into play, which is this module hello, and then you have a parameter called time. That is how we pass devices. And this is the current state of the unikernel. It will soon, in a month's time or so, get a bit easier, because the passing time as a functor argument is may make sense, may have some ideas, but I think it is a bit too complex. So we're getting there. What else do we need for this unikernel to be marshaled and executed? Is to have a so-called configuration file where we select which open packages are used, how the compilation should be, what should be passed in there. So here, the runtime argument that we have a unikernel.hello, the command line argument is passed and marshaled in here. Then we use a package called duration. And then we define how the main function and how the functor looks like. And then we have here a functor that goes from time to a job. And then in the end, we pass in the default time to execute it. In my opinion, this whole config.ml is at the moment a bit boilerplate, and maybe we can actually get rid of it at some point. And then the last step is, now I have these 2 files, the config.ml and the unikernel.ml. How do I compile it? And how do I compile it to the different targets? We have this command line utility called Mirage. And you can just Mirage configure it and then select the target like virt.io, Xen, or HVT, which is the KVM target. Then it gets configured and does a lot of metadata, which OCaml packages it needs, which open packages it needs, and so on. Then you can run make. So Mirage configure also generates a make file, and make then goes along, fetches all the dependencies, builds up a OPAM monorepo, or uses OPAM monorepo to build up a monorepo in order to compile all of that. And then in the end, you can actually run it. And here in this case, we just use Solo5 HVT, which is the process running in the host system. And then it runs the unikernel as a virtual machine. Here we can also pass in hello. And now if my laptop would be able to talk to the project, I would also show it to you that it actually works. But so it is. So next I will come to some case studies that we did. So back in the time we did, so maybe 10 years ago we developed TLS stack, the OCaml TLS stack. And then we wanted to do some proving that it is actually secure. And we weren't sure how do we show people that it is actually secure. I mean, on the one side, it is a purely functional TLS stack, so it's easy to convince yourself that it is secure, but how to show it to people who are not into program languages and who are a bit more stuff. Well, what we did is wrote security Bitcoin Piñata, which was a web for a Bitcoin wallet, and it handed out this private key were successfully with a TLS. I think the microphone is it good? Cool. Okay. The goal was to enable people who are not into OCaml to attack that system and get out the private key of the Bitcoin wallet in order to get out the Bitcoins. And the Bitcoins were 10 Bitcoins back in the time. It was maybe 2,000 euros or so when it was in February 2015. Friends of mine, and we ran it for 3 years until 2018. And then Bitcoin was peaking in price and was up to 200,000 euros as a worth of it. And here on the right, you can see what were the accesses to the Bitcoin Piñata. And you see there were lots of accesses. Lots of people tried to get to the Bitcoin private key, to the private key of the Bitcoin wallet and so on. But nobody actually managed to get the private key, or at least didn't transfer any money. And our idea also with that was that a lot of security challenges and bounties, you have to register, and then some jury has to decide whether it's a good hack or not a good hack, and so on. So yeah, that was one of the case studies, the size I showed earlier. Another case study is the Qubes firewall. And Qubes is a reasonable secure operating system and uses Xen a lot for isolating different processes into different virtual machines, so that if you receive a malicious PDF and you render it, that only your PDF rendering virtual machine gets exploded, but not your mail reader virtual machine and so on. And the Qubes firewall is just a firewall application. It uses 10 times less memory. Libraries, well, we developed a lot of different libraries. You can see them mostly on GitHub. What is the current activity? Let's get to that topic. Well, first of all, Rome wasn't built in a day, so we're still working on it. The ecosystem is, there's Robo Collective, which I'm a member of. There's Tarides and Parsimony, which is companies that develop on Ermin, and a project called SpaceOS. There are a lot of freelance contributors and contractors and open source developers. So what is Robo? Robo is, first of all, we run our own code as Unikernels, like the name server, like the website, and all of that. So we actually try, or we actually execute and find bugs in our own programs. It's a collective of OCaml programmers. At the moment, we have 4 people working to get MirageOS developed. We are a collective, so we are self-organized. We don't have hierarchies in our collective. Our funding comes from public money, so from European Union grants or German government grants, also from commercial contracts and from donations. We apply needs-based payments, and usually we like gift economy. If you have any questions, don't hesitate to reach out to me. We are part of a non-profit company which actually really helps with our goal. What is ongoing work? We just finished 2 months ago Mirage VPN, which is an OpenVPN compatible implementation. We have a next project going on, which is DNS mask replacement called DNS Visor. There's a mailing list project. There's for GNU Thaler, which is a payment system. There's Thaler Exchange that we got funding for and we will work on soon. Recently, we also worked a lot on performance, on Mirage Crypto and TLS and so on. as I mentioned earlier in the Hello World example, we are working on improving the developer experience, so removing boilerplate and removing functors. There's also some work going along for OCaml 5 to support effects and multicore and Unicraft integration. The community meets, as I mentioned, in these hack retreats, which are mostly every year, 1 week in Marrakesh. That is basically the entrance to where we meet. And then we chill out and do some hacking, have some nice food, also eat that food on a shared table, and yeah, enjoy the life. So now there's a call to action. So first of all, join our next retreat. Find out about documentation and community on mirage.io. Tomorrow I will also give a workshop on hands-on MirageOS, so we will actually go to write some code. You can always get in touch by mail to reach out to team@rogo.co. I'm happy to take any questions you may have.
Thank you so much for conducting such an amazing talk. Any questions?
So in some of the early slides, you showed a performance comparison with the same process on Unix or on KVM, I guess. Did you try comparing the footprints compared to a similar lib written in C on Unix, for instance, or using a BSD as a platform? Or do you have like other numbers?
Yes. So first of all, the top slide here, that comparison is in lines of code and binary size compared to a Unix system. So on the right, the big green dot is the Unix system, which is roughly 200 megabytes in size, a virtual machine image that provides basically a web server and the functionality of a Bitcoin Piñata. And it's 2.5 million lines of code. And on the left side here, you have a small green dot, which is the MirageOS Unikernel. So it's 25 times smaller in binary size, and also 25 times smaller in lines of code. That is basically the size comparison. And the performance comparison you were asking about, we just recently, with the ongoing work on Mirage Crypto and TLS releases, there we actually have comparisons compared to OpenSSL. So conducting what is the performance consideration of Mirage Crypto and OpenSSL, or TLS and OpenSSL. Also for our OpenVPN project, our Mirage VPN project, we had a comparison with OpenVPN, so the binary. And there, as you can see it is still ongoing work. We are in the same ballpark, but we are not yet at the same speed. For example, in OpenSSL, some crypto algorithms or some crypto primitives are using a lot of assembly code, and we don't use that. So they're doing a lot of stitches for the specific CPU that you have in order to optimize the hashing and the symmetric crypto stuff at the same time. And we don't do that. But yeah, so we do some comparison also for the Qubes firewall that I mentioned. Here we also do regular comparison, comparing the Qubes firewall with the Unix-based firewall, so with the Linux firewall. And there we are also on par, basically, with the results. And it's still not the end of the game, because we are working, when we did the performance work, we also discovered that inside of MirageOS, we use a lot of allocation of big arrays in the OCaml runtime, which is not part of the GC stuff, but it is external. It's non-moving, so it has been the reason that Xen depends on interfaces that are not moving. But nowadays we use the normal string and bytes type, and that gives us a lot of performance improvements, and we are not there yet with getting rid of all the big array allocations.
Thank you.
Thanks. Any more questions? Okay. Yeah, let's do it in order.
Thank you for a very informative talk. If I want to use Bluetooth, do I have to implement it in OCaml?
Yes, maybe. Or you have to define you run basically the Bluetooth in some virtual machine and then marshal it to TCP/IP or something like that. Could you implement it in OCaml?
I guess my question is more about, if I have a commercial project that requires integrating with existing, let's say, custom drivers or alternative network stacks, what's the story for integrating with those from Mirage? So what you're saying is that we need to build a TCP bridge between the two components, is that right?
Well, there are multiple options. So one option was also that on an ESP32, it's a very small microcontroller, there someone actually took the existing drivers for the wireless network card and for the serial console or something like that, and just used the files and embedded them into MirageOS, and on that hardware complete operating system only in MirageOS. So there was no Linux involved anymore. So if you have interface drivers that are written in C, you can also just use them. So there's no need to redevelop everything in OCaml, while you can do that and it works. But yeah, you have some choice, and there's always a question on your specific application on what makes the most sense.
Okay, thank you.